Hey guys, welcome back to my channel on all things Excel, math, and business tutorials. Today we're going to be discussing a very important concept known as decision trees. Now, decision trees are basically maps that show all the options and directions of something that you can have happen or might have happened had you made a decision. It's the same way to map out the same decisions we make every single day, like will I wake up at this time tomorrow or not? What happens if I eat this food versus that? So to explain this, we're going to start with an example. Let's say that a new airport is being built, and we don't know where it's going to be built. There's two possible options. Maybe it's built at location A or location B. The problem we are faced with is that we're a hotel chain, and we want to make a hotel to maximize revenue based off of this airport. The problem is we don't know whether the airport is going to be built at location A or location B, and that leaves us with the decision to make, because if we leave it at A and it's built at B, we won't make as much money, and the vice versa. So we want to hope to make sure our decision maximizes the most profit for us. So let's assume that up here we have the cost to build the hotel at location A is $18 million. The cost to build it at location B is $12 million. Let's also assume that there's a 40% probability that the airport will be built at location A and a 60% probability it will be at location B. And furthermore, the revenues will generate from all these outcomes. So if we build our hotel at A and the airport is actually at A, we stand to make 31 million in revenue. Alternatively, if we build it at A and the airport turns out to be at B, we'll only make 6 million revenue. If we build it at B and the airport is at A, we'll net 4 million revenue. And if we build it at B and it's built at B, we'll net 23 million revenue. So the third chart I have here is the profit. So for example, if we built it at A and it was built at A, we make 31 million revenue, but we have to remember to take out the cost, and the cost of building at A is $18. So 31 minus 18 is the $13 in profit we made. Just as if we were to build it at B and it's made at airport A, that's $4 million. And the cost at B is 12. So we only made $4, but we spent 12. 4 minus 12 is negative 8, and so on. These are our revenues. So now there's so many concepts, and this table looks very confusing. It'd be much easier to visualize with the decision tree and see how simple this problem really is, as opposed to how complicated all these tables and graphs may appear. So over here I have a decision tree marking the 3 decisions. Now there's actually 4. First, we could build it at A, we could build it at B, we could build it at both, or we could do nothing. But obviously if we don't do anything, we're not spending any money, we're not making any money, so we don't need to move further with that decision. So here are our 3 choices: build at A, build at B, build at both, and we're trying to figure out which one is the best option for us. So here we go. Building at A, we have 2 options. We build at A and it actually is at A, which is a 40% chance. And we build at B and it's actually built at B, which is the 60% chance. Ignore that, we'll come back to those numbers later. Same thing when we build at B, it could be at A. Or when we build at B, it could be at B. And lastly, when we build at both, here at the bottom, it could be at A or it could be at B. Now, how do we calculate the expected values? What's our probability? What are we going to get? So these are what these numbers here mean. If we build at A and the airport is built at A, we stand to make 13 million, remember, from our graph up here. Also, we have in our graph for profits, if we build at A and the airport's at B, we're going to lose $12 million. So how do we calculate this expected? Remember, we have airport A 40%, so we take that 40%, or 0.4, we multiply it by the 13 that we will get if that's the outcome. We add it to the alternative, the 60% of B, times the negative $12 millions we'll lose. And we get negative 0.4 times 13 plus 0.6 times negative 12, which is equal to negative 2. So our expected outcome if we build at A is -2. Now, we'll do the same thing for if we build at B. So again, building at A is a 0.4 chance. So these numbers, -8 and 11, come from our table up here. We have -8 million loss if we build at B and it's at A. And we have 11 million profit if we build at B and it's at B. Again, the probabilities are the same. Building at A is 40% and 60%. So to calculate our expected, we have the 0.4 times the -8 when it's at A, plus the 0.6 times the 11 million profit when it's at B. We get 0.4 times -8 plus 0.6 times 11, which is 3.4. So our expected here at building at B is 3.4. Lastly, we do the same and final calculation if we build at both locations. Again, if we go back up to our table, we see building at both, and if it's at A, we net 5 million. Building at both, if it's at B, we lose 1 million. So, probabilities are the same. We have the 0.4 times the 5 that we expect if it ends up at A, plus the 0.6 times the -1 that we'll get if it's at B, and we get 1.4. So our expected at building at both is 1.4. Now again, we're business owners. The idea and objective we're trying to do with our hotel is we want to maximize the revenue. So we look at these expected values. We see building at A, we're expecting a -$2 million revenue. Building at B, 3.4 million. And building at both is 1.4 million. So based on these conditions and these probabilities we have given, we see that the best option for us is the highest expected value, which in this case is building at B, where we're supposed to net 3.4 million expected. That is how decision trees work. It's an easier way to take all these chunks of information and map them out. And this is the same information we do every single day in our minds when we decide to do something or not do something, or if we're thinking about things. And decision trees are a great way to visualize it and put it out on a spreadsheet, a chart, a graph, so that you can see all the outcomes, all the options, plainly and clearly. Decision trees are a very important concept and help make sure you see all the outcomes when making a decision, and can help you greatly benefit in terms of solving complex problems by breaking down your options and your alternatives and having you have a visual representation you could use to analyze. Thank you guys for watching this video. I hope it helped. If you liked it, please like, comment, subscribe, share it with a friend, and we can help out as many people as we can. See you guys in the next video.